So, scientific notation is a number between 1 and 10 times a power of 10. And so we write numbers in scientific notation. First thing you have to do is figure out where you can put the decimal point in it to give you a number between 1 and 10. So in number 1, it would need to be 2.5 times 10 to the, and then we say, here's where we put the decimal. How many do we have to move it to get it back to where it started? So 1, 2, 3, 4, 5, 6, a total of 7, and that was to the right, so it's positive 7. Number 2, where can we put our decimal? Between the 4 and the 3, because we put it after the 3. 43 is not between 1 and 10. So here's where we put it. How many have to move it back? 1, 2, 3, 4. And this time it's to the left, so it's negative 4. In number 3, you can't drop off zeros if they're in the middle and being placeholders, so we need to keep those zeros, so we need all of those numbers there. Because 3.0097 is between 1 and 10. And then we say, here's where we put it. How many do we have to move it back? 1, 2, 3, 4, 5, 6, 7, 8. Again, to the right, so it's positive 8. Here we'd have to put it after the 2. So 2 times 10. And if we put it after the 2, 1, 2, 3. And that's to the left, so times 10 to the negative 3. Now we're going to go in the reverse, and again, remember, we're moving the decimal point. It does not mean how many zeros to add. So this is going to tell us to move our decimal point 5 places to the right. So write down your number without the decimal, and then moving it 1 behind the 6, 2 behind the 8, 3, 4, 5. Here's where I don't really want you to put all those, like 3, 6, 8. I don't really want this, because then it's hard to tell what's a decimal. So in this one, we're going to write down 7, 4, 1, and again, we have to move our decimal 4 places to the left. It was behind the 7, so in front of the 7 is 1, 2, 3, 4, put our decimal point. Now we're going to do some problems that involve scientific notation, and I'm going to let you use your calculator on part of this, but we're going to use our law of exponents that we've been working on. So we're going to multiply these two numbers. If you need a calculator to do that, that's fine with me. All right, so if you multiply 5 and 2.9, you're going to get 14.5. And now we have powers of the same base, so what did we learn about exponents? You can add their exponents and we're going to get negative 6. But I do want my answer to be in scientific notation, and the problem here is 14.5 is not between 1 and 10. So it would become 1.45, and here it gets a little tricky. Here's where I put it. How many do I have to move it back to where it started, which is 1 to the right. So if I add a positive 1 onto negative 6, I'm going to get negative 5 as my exponent. So a little tricky there. Again, in number 8, I need to divide the two numbers, and again, that's where a calculator can help you. So we're going to divide those, you're going to get 0.245. And then what is the rule when you're dividing powers of the same base? You subtract the exponent, so we get 10 to the 4th. Is this in scientific notation? No, because 0.245 is not between 1 and 10. So we would need to move our decimal over here, and we say how many do we move it back to where it started? To the left one, so that's a negative 1 added on to 4. Would give us an exponent of 3 here. So make sure they're still in scientific notation. And now we're going to try to use this to help us do some word problems. So again, make sure you read the problem and understand it. A cubic millimeter of blood contains about 5 times 10 to the 6 red blood cells. An adult human body may contain about 5 times 6 cubic millimeters of blood. So each one of those has this many blood cells in it, red blood cells in it. So we end up needing to multiply the two. So that's the first thing we need to do, is write down what actually the problem is we're going to be doing. And I thought these numbers, I maybe made a mistake typing, but I went back and checked. So just like last time, we're going to multiply the two numbers in front. Hopefully we don't need a calculator for that. Times 10 to the, add the exponents, we're going to get 12 there. Is it in scientific notation? No. So 2.5. Here's where I put my decimal. I have to move it 1 to the right. So that'd be positive, so this becomes 13 when I add the 1 onto my 12. And one final word problem we need to do. Population of Arizona is about 4.778 times 10 to the 6th people. I'm not really sure when the statistic was. The land area is about 1.14 times 10 to the 5th. What is population density? So I want to know how many people per square mile. So if I know the total people, 4.778 times 10 to the 6th, and the total land area, I need to divide the two to see how many people would live in 1 square mile. So again, if you take your calculator, divide 4.778 by 1.14, I believe I rounded off to 4.19 times 10 to the first power. And that would be scientific notation. This one, it might be a good idea to write it. What would it be? What is the actual population density? Probably you would say about 42 people per square mile.